of surface. So initially it is being elongated. The spring is elongated and released. So natural length of the spring, we'll take it. This is related to natural length. I'm not bothered equilibrium. This is related to, because right hand side is spring will be elongated. Left hand side of this red line, the spring will be compressed here. So what was the initial? Some elongation x naught is given. X naught is what? Elongation. I released it and this surface is rough. So kx naught, check it, kx naught greater than mu mg as it is. So it will accelerate. Then finally, so what it will do? It will reach to the this position. I'll show this one. So let this be the x1, you take it. Then again I'll check it. Spring force greater than, is it mu mg? If it is greater than mu mg, again the block will move towards right. Somewhere it comes, it will have some velocity, say v. And because of this velocity and the friction will be acting. So what's happened to block? Block again will proceed like this. And it come to here the instantaneous rest. So let me check this distance, x2. So again, I'll check the kx2. Kx2, if it is greater than mu mg, again it will vibrate. So like this, the block, what will happen is going to describe to and fro motion. But what will happen to now its displacement, the maximum compression, what will happen to that value? It keeps on decreases, no? So you can take this to be x3. Take this x4. So continuous development, the energy in the spring, the energy of the mechanical energy of system continuously decreases. Why it decreases? Because it has to overcome the friction. Finally, where it should come to rest? Don't say mean portion. So somewhere let it come to, finally what will happen? The compression in the spring or the elongation in the spring will not be sufficient. So somewhere here, I'll write, say this is kx, where it is just is unable to overcome the friction, and the friction acting will be, you can just say like a equal to static or equal to mu mg, let's say that one. And this will be the final. So what happened? The block just has not moved, and that one, it has described to and fro motion with a decreasing amplitude, and finally it has come to rest here. So look at the question, what it is. How many times did the spring become relaxed during this process? Find the final deformation of spring when the block stops. He is asking this x. How to get that? Final deformation of the spring when block stops. Final deformation means kx should be equal to mu mg. It's very simple. Then how many times did the spring becomes relaxed during this process is asking. How many times means, sir, like what to do? Yes, you have to really work out and check how many times it is this one. Now as it oscillates, so what do you mean by one oscillation? When it moves from like this will become one oscillation. So this will become one oscillation. So again, this will become second oscillation. Surface smooth, okay, there's another thing. Surface smooth, it will continuously oscillate, nothing to do. Don't get deviated. Huh? Just focus on the problem. Don't get deviated, man. Don't get deviated. Just focus on the problem, what I'm telling. Okay, first oscillation, there's a second oscillation. I'll ask you one simplest question. What will happen to the decrease in energy in every cycle? From this position to this position. So the block will go, this is one oscillation, then this second oscillation. So what happened to the decrease in energy? will be same. Sir, how come? How come here x1, x2, x3, x4 are different? You write the equations and check it. No, the decrease in oscillation energy for every cycle, the decrease in energy for every one oscillation will be equal. How much of energy decreases in first oscillation? That much of energy will decrease in second oscillation. With that, what happen? You can write a generalized equation. You will get a formula. Using that formula, you can write time taken for so like how many how many oscillations we can have a generalized formula. I'll give that formula. Check it. If unable to do, I'll discuss in coming classes. I'll give that formula. If you can derive that formula, it'll be easy for you. So number of oscillations, the formula. Actually, if you solve this for n oscillations, no, finally you'll end up with this is number of cycles. Actually, you have to do this one. So how to calculate the total distance moved? Okay, how to calculate total distance moved? Can we calculate this total distance moved? So kx naught square by 2. This should be equal to mu mgs minus kx naught k x square by 2. And what is kx? Kx should be equal to mu mg. Because finally it has come to rest. I'm applying work engine. And what is mu mgs? Total distance covered. From initial position to the final, what is the total distance covered? That is what S here. So can we calculate the distance covered? Yes. From the distance covered, again you have to work out if you know x1, x2. Instead, what I suggest you, better derive a formula and substitute value of x naught mu and. So I think this will benefit you a lot in exams rather than manually working. Two ways you can do problem. You keep on solve till here and check, keep on count number of oscillations. So like this, it may end up 5, 6, 7, 8, that one. Or else bring a generalized formula, here substitute values. Either of approach you can try it. It's a very simple problem, but your background should be clear. You should be able to analyze with the help of the diagrams. Bring this generalized form. How to bring this generalized formulas? Second oscillation. You write equation for third oscillation. Then check all these equations, no? So finally you'll end up with this generalized equation. This is for n oscillation. Like this, the nth oscillation will come. Try this one, I'm just giving. And what is this? Total distance covered. If they ask you find the total distance covered by the block, you need not to do anything. No need of any formula. Directly. Initial potential energy of the spring. As it moves, friction does negative work, no? And the friction is a non-conductive force, depends on path length. S, what is S? S is the path length of the block for n oscillations. S is the, what is S? S is not displacement, path length for n oscillation. As friction is a non-conductive force, work done by friction should be equal to what? Friction into what you should take? Path length, not displacement. So the total distance moved by the block to come to rest. So you'll get this one. So you know x naught, you'll get S. Then you know total distance. So calculate x1, x2, x3, x4, like that, so on. If 10 oscillations, you have to draw 10 oscillation diagram, then you have to work out. So I suggest you go for generalized formula. There you substitute this one.